Welcome. My talk is a little bit language specific. So here is a glossary for you. Month, fly, man, honey, horse, day, hour, and housefly. That's probably all you need to know about Estonian. You don't need to know how to pronounce all that stuff. I am going to talk about written language. So, everything memorized, then the topic I said, Estonian Natural Language Toolkit. I think I will call it just Toolkit today, for short. I'm Paul. I'm quite ambiguous from the University of Tartu, but also from Fujitsu. But today's talk, the toolkit, is related only to the University of Tartu and STACC. STACC is a company close to University of Tartu, Computer Science Institute. And Estonian Natural Language Toolkit, or Toolkit, that's an open source software. It's in public GitHub repo. Everyone can download it, everyone can use it, everyone can install it. Currently it works for the installation packages work for Python 3.5 and Python 3.6, which concerns the newer version 1.6. The older version 1.4 of this toolkit is also available, but that is I don't know much about 1.4. I know that some people use it, but I know quite a little. I have been involved with developing 1.6. I'm the developer guy. I'm not the user of the toolkit. So to prepare the presentation, it was quite a hassle for me to find examples and work it out how a user sees that. And therefore, well, I know more about the structure of the toolkit and I think less about the usages. And as it is an open source software, everyone can use it, and so I have no overview how many users there are. There aren't too many downloads, but what the users do with it, well, no one knows. But I start with a structure. That is what I like the most, I think. On this slide, everything which is bold is a Python class inside the toolkit. The main class is a text class. Of course, everything I say today, I try to be simple. And since I try to be simple and say only simple things, then it means that I won't tell you all truth. So everything is simple here. Here is a simple text class, and the text class consists of basically two things. One is a text string. Here it is. Mees oli kärbes. You should understand what that sentence means. And maybe Estonian speakers notice that this sentence is ambiguous. We shall talk about that later. And the second thing that, and we are talking about visualization the toolkit, which in active work currently. The first thing is a text string, and the second thing that the text class contains is a list of layers, or dictionary of layers. Here on this picture we can see only one layer, but there can be finitely many of them. A layer again is a class which contains it knows its name, it knows its attributes, and it knows its spans. So a simple way of thinking of layer is a list of spans, and at the same time it is a dictionary of spans. It means that layer can be indexed by integers, but also by the special kind of indices called base spans. So a list of spans, in this case, for every word in the text there is one span, and a span again is a simple thing. It contains its base span, in this case elementary base span, but that's not important, it's elementary, and a list of annotations. So very often there is only one annotation, but in general there might be more than one annotation. Here, the first word here has two spans in the layer of morphological analysis. You can see here lemma and form. These are linguistic notions. Linguists like them. I don't know much about lemmas and forms. Lemma, that's a form of word you can find from the dictionary, and form, the SGN means something like singular and nominative or something like that, and that EN here is inessive form of word. So the first word here is ambiguous, maze. It might mean a man, and it also means, or might mean, in honey. So the fly is in honey, or the man is a honey. Oh, sorry, a man is a fly. So much about the structure of the toolkit main classes. We can also see it in live, I hope. It takes a few seconds to make the first import. Here is our sentence, means and we analyze it morphologically. It will get several layers, a layer of words, a layer of sentences. Here you can see the layer of morphological analysis. Here the toolkit has decided that the first word in the sentence is mes, it's a man, not a honey, for some reason. That is because by default the disambiguation is switched on, so the honey part is removed. And let's have a longer example. This, I have chosen some words from the Wikipedia article about housefly. You can notice that I have chosen the sentences which contain numbers and some time units, like päev, which day, and kuud, which is month, We will work on these later on. First of all, let's just analyze the morphology. We shall need that morphology later. On the previous slide, I showed you the layer of morphoanalysis. That was the layer of morphological analysis. Here on this slide, you can see all the layers I mentioned before: sentences, words, morphological analysis. The thing is that if you want to have a morphological analysis, then first you need to find the words and sentences, and then you can calculate the morphological analysis for every word. So what can we do with a text object? We can iterate over the text object. What we can see here is we have a text object and its layer of sentences. And, well, we can iterate over the layer of sentences. The layer of sentences, it turns out it is a list of words, again, simply speaking. So we can iterate over the sentences, and just for fun, what we do here, we print out the text which corresponds to the sentence in case the text string, the raw text string in the original text equals toakärbes, housefly. Let's try it. We found one sentence containing the word toakärbes. Well, it's here, as you can see. But in our original sentences, there were many, well, actually four sentences, each containing, speaking about flies. Here is toakärbes, here is toakärbs, here is no flies, and here's again toakärbs. So we have a challenge to find all these words. And that's different from English. In Estonian, words tend to change form more than, well, in English, for example. Oh, that was bad. So what can we do? There are several options. Let's just try the toakärbs form. Yes, it found the toakärbs here. What else? We could abbreviate that toakärbs. Let's just remove the last two characters and try this way. Okay, that works. Toakärbes, toakärbs, both were found, and well, one more obvious thing to do is, of course, was it lower? Yes, I think it was. So the usual string operation. So we found one more. Actually, we found all occurrences of fly. But that is, of course, a hack, ugly hack, because it might create false positives. So there is one other way using the tools of the toolkit. Let's use lemmas. Toakärbes is a lemma of toakärbs, and here we don't need to say lower, we just say lemma. The layer of morphology was, as you maybe remember, it is ambiguous. One span may have more than one annotation. So if I ask the word text.lemma, then I get a list of lemmas. So therefore the in stays here. That's true. word.lemma. And that's a nice way to find all the occurrences of different forms of the word from Estonian text. Now we can go on. One part of the toolkit I have not yet covered are taggers. Taggers are interfaces of abstract classes that create layers. You don't need to read all through the next slide. Just for an example of a simple implementation of a tagger. As I said, the goal is to create a layer. Let's see, we shall create a layer called temporal tokens. We are going to annotate the parts of text, or the tokens in the text that might be, again, part of a temporal expression. We shall annotate or find the words second, minute, hour, day, week, month, year, century. Of course, in our example, there are only, not all are present. There were, I think, a day and month. And we shall also annotate or find numbers. And if a word or a token in a text is not a number and it is not a time unit, then we call it just cap or whatever. So, now we have, oh, I forgot to run it. Now we have a temporal token tagger, which creates a layer of temporal tokens. Let's initialize it. And also tag the text, and here we can see a temporal tokens layer appeared. And well, let's look at the layer. The highlighting code is somewhat clumsy. The future of this toolkit is to make it nicer. It's in active development currently. But what we can see here, we have found all the tokens that might be a part of a time expression. Here is 100 to 120 pieces, which is not, of course, a time expression, but we have annotated or found everything from the text. Now the next goal is to find out which combinations here express time and which are just chunk in the sense of time expressions. Here is 2 months. This is 8 to 12 millimeters, that's understandable. Here is a time unit, but no number. Some days, it says. To find out which of these are time expressions, I have decided to use grammar parsing tagger. It's a ready-made component of the toolkit, and we just have to define a grammar. Again, it is done very easily. Here you can see the grammar, which says that if there is adjacent number and unit, then it is a time expression, or temporal expression. And that's it. Here is adjacent number and time unit, and so that should be a time expression. Here is a time unit, no number, so it is not a time expression. Okay, let's try and run it. And as promised, it found all the time expressions. 8 hours, 3 days, 2 months. Well, this says 15 to 20 days. My tagger is not so smart. That's just a demo tagger, so it didn't understand that it's a 15 to 20 days. It thinks that that's 20 days. So yesterday I showed my slides to my colleagues. One of them pointed out that, well, Paul, you see, we have a Tmx tagger. Of course we have Tmx tagger. Every natural and easy thing to do is implemented in Toolkit. So we have a taggers for morphological analysis, for time expressions, for syntactic analysis, for addresses, and so on. And what I'm not going to show you in practice, the use case for grammar taggers I'm most familiar with is actually annotating data from health data records. Because a lot of health data, at least in Estonian health data records, are just a plain text in free form, just as doctors have written it down with they make mistakes. That's quite a challenge to extract all the measurements from the health data. That's the private use case. I can't show you, but it is quite similar. So that was just a demo, and there is a real Tmx tagger. Well, it turns out it works the same way as my demo tagger. Although in code it's about 500 lines. The layer that the real Tmx tagger creates is more sophisticated. There are much more attributes here. For this example, unfortunately, most of the values are none, but in practice they, of course, might not be none. And the last thing I want to tell you about is PostgreSQL interface. You can store your text object in Postgre and then search and iterate and whatever. The only thing you need is the toolkit and also access to Postgre database. And you should store your access data in a standard BGBus file. Here we set up the schema and create a collection. Well, in practice, the schema might already be set up, but well, here in my computer I set it up. Then the next thing, the typical use case, is to populate the collection. quite typical use case. We open a text file. I have a text file here. That's again a copy from the Estonian Wikipedia. I have somewhat edited it. I have removed hyperlinks and titles. No. And what we shall do, we open the file, we analyze morphologically. That means that the sentences are also annotated. We split the text by sentences, so we get about 100 or 101 sentences, and we insert these sentences one by one into the collection. That's what we can do. Took 1 second, yes? My collection is created. Here is a little bug. I think there should be 101 texts. Here it says 100. Okay, let's see at the collection. 101 texts at the collection with the layers, words, sentences, morphological analysis. Okay, but we have our temporal expression taggers. First the temporal token tagger, and then the temporal expression tagger we used before. We can use them on the collection as well. First, we run the temporal token tagger successfully, then we can run the temporal expression tagger. Also, it seems that it runs successfully. So, we have 2 more layers in our collection now, temporal tokens and temporal expressions. Just as with a text object, it's quite similar with a collection of texts. Next natural thing to do is to iterate the collection. We create a generator here, and let's see the examples of temporal expressions in the collection. 8 hours, 3 days, and so on. Oh, no more. Let's go on then. We have also possibility to search from the collection. Here we shall search for words kärbes and toakärbes, having words that have lemma kärbes or lemma toakärbes. Here's a clumsy highlighter, and here are the words toakärbes and kärbes highlighted. Quite many of them in the text. It's text about flies, and so on. And just close, delete the schema and close storage. This project, as I told you, we have developed in University of Tartu, at STACC and at the Institute of Computer Science. There are many more contributors. Here are the main ones. I think that's all about Estonian natural language toolkit. I would like to thank the organizers for the wonderful opportunity to speak here. The organizers have done good work. I have so far enjoyed it very much. Thank you. And well, not so quick. I have a habit to use formulas in my presentations. So far, I have never spoken without any formulas, and I don't want to break that habit. So, just for fun, one final slide with a formula for you, which tells you about the future of the C language. What about the future of Python? That's what we find out today, I hope. And I'm eager to find out where here lies the Rust programming language. I hope to find out soon. Thank you.
Okay, how very insightful. Thank you. Let's get to the questions. Okay, so the most popular, the most liked question that we have at the top: how much Python code does your library have compared to lower level languages?
Most of the code I have written is in Python. We also have some JavaScript. The highlighted part is written in JavaScript, not by me. And there is Java and C, but that is also not written by me. So I know little about that. This library is mostly based on Python.
Okay, great. Okay. I hope I don't pronounce this wrong. About EstNLTK toolkit? Yeah. Presentation, what is the tool that you're using to run pieces of code? Some extension for Jupyter Notebook?
Yes, so that is an extension for Jupyter Notebook. I have here a note about that. I found Rise. I'm using that first time here. It seems to run fine.
Right, cool. Okay. Then we have the question, how much Python code does your library, no, we've done this. It's on the top now. What has been the biggest challenge with NLP in Estonian compared to NLP in English?
Well, I think the morphology of Estonian is a challenge. Otherwise, languages are similar, and this toolkit except the language-specific part as morphological analysis and other. The core components are quite applicable to English or whatever languages, because we use, of course, Unicode. You have 8. Morphological analysis is a challenge, I think, but the linguists know better. I'm not the user, as I said.
Okay. Let's move to the next question. How lemmas for each word are known? Did you just write what is the lemma for each word?
There is a component imported to the toolkit called vabamorph. That's written. Actually, I don't know. It's written before me, and I'm only using it. I don't know anything about lemmas. The vabamorph analyzer knows, this toolkit just wraps the vabamorph analyzer to a friendly format we can use in Python.
Okay. Where is this library used in the real world?
As I told you before, one example is for extracting data from health data records. Linguists like it to do their science, whatever science they do, I don't know. I'm not the user. They can count numbers, lemmas, part of speech tags, whatever they are interested in. Yes.
Okay, I'm going to take the second question first, so then we can end on that, the note of question that's before. Why Python?
I think that's because I hope we agree that Python is a good language, and it's convenient to use and convenient even for linguists. That's why.
Yeah, and it's PyCon, so. Have you tried generating text from Estonian n-grams?
No, I haven't. Again, that's for the Toolkit's users to do.
Okay. And then, what is your greatest fear when it comes to the future of technology, say by 2030?
Well, so far, I haven't thought about it. I didn't know I have to fear 2030. So, currently, no fears.
Okay. Great. Perfect. Thank you so much, Paul. That was insightful. Give a big round.